Now we're going to use the root test to determine whether the series converges, diverges, or the test is inconclusive. Root test is the same thing. If it's less than 1, it converges. If it's greater than 1, diverges. And if it's equal to 1, it's inconclusive. But here, instead of taking the n plus 1 term, you're going to take the nth root of the term here. So if you see a lot of like n in the exponent, you could try ratio, but here root test works better. Because what's happened is when I take the nth root of it just cancels with that. Right? And that's nice. Dominant terms 2 and 3. 2n and 3n, so this is 2/3. It's less than 1, so it converges. Limit n goes to infinity. The nth root of this whole thing, 2 to the n squared over 3 to the n. It's really going to cancel out the n's here and here, so it's going to be 2 nth root of n squared over 3. I can bring out the 2/3 and just look at this one here as this is n squared to the 1 over n, so n to the 2 over n. This becomes infinity to the 0. So this limit is an indeterminate form. So let's evaluate what this limit is. Remember, the trick to convert this indeterminate form is I do e to the ln of this. And that brings the exponent out. It becomes e to the 2 over n natural log of n. And so I'm just taking the limit. Actually, let me get rid of this limit part. I'm just taking the limit of, so I want to simplify this part. Take the limit as n goes to infinity of this whole thing, 2 over n ln of n. If I write it as 2 ln n over n, it's infinity over infinity, right? So then I can, this is indeterminate. And so I can use L'Hopital's rule. Take the derivative of the top, 2 times 1 over n. Derivative of the bottom is just 1. This is 2 over n. As n goes to infinity, this goes to 0. That means this whole thing approaches e to the 0, which is equal to 1. That means this whole thing, this here is just 1. So this equals 2/3. 2/3 is less than 1, so it converges. Honestly, ratio test probably would have been a little bit easier on this one. But root test is fine. Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.